Today we're going to review for our big quiz over trig verifications. So part of what you're going to be responsible for filling in is what's here on this page, and the fact that sine has a reciprocal of cosecant. So cosecant has a reciprocal of sine, and cosine has a reciprocal of secant, and secant has a reciprocal of cosine. Tangent has a reciprocal of cotangent, and cotangent has a reciprocal of tangent. And of course we can take tangent a step farther, because we can say that tangent is sine divided by cosine, and cotangent also has a reciprocal, or also has a definition of the cosine divided by the sine of theta. And after we talked about those, then we went into the Pythagorean identities. And our first Pythagorean identity that we did is we said that sine squared theta plus cosine squared theta equals 1. And consequently then what we could also say is that sine squared theta equals 1 minus cosine squared theta. And cosine squared theta equals 1 minus sine squared theta. Well, from there, we came up with the next identity, which is the 1 plus cotangent squared theta equals cosecant squared theta. And we could rearrange these so that we could say that cosecant squared theta minus cotangent squared theta equals 1 when we subtracted cotangent from both sides. Or we can say that cotangent squared theta equals cosecant squared theta minus 1. And I actually think that I did those backwards from the way that I did those in the notes. But those are correct there. I subtracted 1 from both sides. And then when we look at our other identity, it is tangent squared theta plus 1 equals secant squared theta. And we can rearrange this. We can subtract 1 from both sides, and we get tangent squared theta equals secant squared theta minus 1. Or we also can say, let's see, if we subtract secant squared, sorry, not subtract secant squared, but secant squared theta, if we subtract tangent from both sides, and we get that equal to 1. And there's our identities that we can use to help us verify. So if we take a look at our first identity, remember we're looking for the more complicated side. It says establish each identity, show all the steps. And one of our really helpful pieces here is that we turn everything into sine and cosine. So when we look at secant, let's rewrite secant as 1 divided by cosine of theta. And cosecant is 1 divided by sine of theta. And then for a moment here, I'm just going to leave cotangent of theta. And we're going to multiply in the top of that fraction. 1 times 1 is 1, and then we've got cosine of theta times sine of theta. And we're taking that top of that fraction, and we're going to divide by cotangent of theta. Well, let me actually write out here beside this, then, that we've got 1 cosine theta times 1 of sine of theta, and cotangent of theta is cosine of theta divided by sine of theta. So I had to backtrack for a minute, but we can multiply here in the top, and in the top of the fraction. So we take 1 times 1 is 1. And we take cosine of theta times sine of theta, and that's where we get the bottom. But then we're going to divide by cotangent of theta. And let's go old school here and divide by that. Instead of writing it the way we have it written above here, let's rewrite it by dividing by cosine of theta divided by sine of theta. Well, now, what's going to happen is when dividing, don't ask why, flip the second one and multiply. So 1 divided by cosine theta sine theta is going to be multiplied by sine of theta divided by cosine of theta. And what we're trying to do is we're trying to turn this left side of our equation into the right side of the equation, which is secant squared theta. But remember, we're only working on one side. We don't want to move anything around across the equal sign. We want to turn this left side into the right side. But we have it written in multiplication format now, so we'll multiply the top of the fraction. 1 times sine of theta is sine of theta. And then cosine theta, sine theta times cosine theta is cosine squared of theta times sine of theta. Once again, we're trying to get this to turn into secant squared of theta. Well, then we can ask ourselves, on this left side of our equation, do we have anything exactly the same in the top and in the bottom? And we do. Well, remember, sine divided by sine is 1. We have 1 over cosine squared theta. Well, 1 over cosine squared theta, if you look above here on your paper, you see that 1 divided by cosine is secant. So 1 divided by cosine squared is secant squared theta. And then what we have is the other half. It matches the other side of the equation. Let's look at the next one. Cosecant squared theta times cotangent theta minus cotangent cubed theta equals cosine theta over sine theta. Well, we have lots of techniques, and something that you should consider doing is looking over your yellow identity sheet with the suggestions or tips on how to help verify. The first thing that I see when I look at this problem is on the left side, I see that there's a cotangent in the first term and there's a cotangent in the second term. And I can recommend that we factor a GCF of cotangent of theta. When we factor out a cotangent of theta, we have cosecant squared theta minus cotangent squared theta. And we've got squared in there. So we factored out the greatest common factor. We've got cosecant squared theta minus cotangent squared theta. I wonder if we look above here, if that's going to be helpful for us or not. Do we have anything that says cosecant squared minus cotangent squared? And it's actually written in green here on the paper. It's from the middle of the 3 Pythagorean identities, right there in the very middle. Cosecant squared theta minus cotangent squared theta equals 1. So cosecant squared theta minus cotangent is 1. We still have this cotangent theta out there. We're trying to turn this left side of the equation into the right side of the equation. And cotangent theta times 1 is cotangent theta. Well, cotangent of theta can also be defined as cosine of theta divided by sine of theta. And that's what we actually have over here on our right side. Number 3. Tangent squared theta divided by tangent squared theta plus 1. Whenever I see a squared, I always wonder, is there anything that I can use from my Pythagorean identity? So if we go back and look at the front page, or maybe you're looking at your yellow paper, is there anything in there about tangent squared theta plus 1? Well, it's to the far right, kind of in this purplish pink color. Tangent squared theta plus 1 equals secant squared theta. Now let's go back and instead of writing tangent squared theta plus 1, we'll leave our tangent squared theta in the numerator. But tangent squared theta plus 1 we're going to rewrite as secant squared theta. Now, maybe as an extra step here, what this means is it means tangent squared theta divided by secant squared theta. And I write it like that because we are probably better off if we rewrite tangent as sine squared theta divided by cosine squared theta. And if we rewrite secant squared theta with its reciprocal identity as 1 divided by cosine squared theta. Now ultimately, again, we're still trying to turn the left side of the equation into the right side of the equation. But when dividing, don't ask why. Flip the second one and multiply. So this is sine squared theta over cosine squared theta divided by 1 over cosine, which means we're going to flip it. Cosine squared theta over 1. When we multiply these fractions, we're going to multiply the tops of the fractions together, and we're going to multiply the bottoms of the fractions together. So we get sine squared theta, cosine squared theta, divided by cosine squared theta. And then we can ask ourselves, do we have anything exactly the same on the top and on the bottom? Well, we've got a cosine squared that's on the top and on the bottom. So cosine squared divided by cosine squared is 1, and we're left then with sine squared theta. And if I go back and look at the top of the problem here, sure enough on the other side, there we verified the fact that the left side of the equation is equivalent to the right side of the equation. Problem number 4. I think I will put this on the next video.